the world to teach and conduct research at ITS. These opportunities have made international joint research and other international activities successfully performed. Like IUP, students and lecturers from other programs have also contributed to the ITS to teach and conduct research at ITS. Numerous appreciations earned exemplify Institute's excellent performance. But technology and academic excellence is not the only goal of the Institute. Students are guided to apply their knowledge for the welfare of society. Because to note a new life-changing history, technology must advance humanity. ITS, Institute Technology, 10 November.
Distinguished guests, ladies and gentlemen, before we start commence the program, and here are the following webinar protocol. For each participant ID, please use your real name following with your origin of institution. All of participants are expected to mute the audio and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room, and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
Good afternoon, ladies and gentlemen. Welcome to the guest lecture series on Sustainable Development Goals, or GLS SDGs today, Thursday, March 10, 2022. I'm Dio from ITS Global Engagements, and I will be the moderator for today's lecture. So once again, thank you for joining our guest lecture series on SDGs today. And before we start our agenda, let me inform you some of the rules for this event. So first, please adjust your name or ID screen using format name_campus. And then second, during the lecture, you are advised to turn off your microphone and only turn on the microphones when the moderator gives the chance. Third, please fill your attendance at the links that will be given by committee in the chat box. And for participants who wish to get an e-certificate and stamp, please fill the attendance 15 minutes after the session starts. And fourth, participants who wish to ask questions during questions and answer sessions, please send your questions at the links also will be given with the committee in the chat box. Or you can ask directly by using the raise hand features. So, ladies and gentlemen, today we will have not only one, but three speakers from three different countries that will present their expertise and research related SDG number 7 and 13. So before we start our agenda, allow me to deliver our schedule today as follow. First, opening and introductions to speakers. Second, lecture sessions. Third, Q&A sessions. Fourth, certificate awarding. And fifth, closing. Now, before we proceed to the next agenda, let me introduce our first speaker. We have Dr. Somporn Chuai-Aree from Prince of Songkla University. Hello, Dr. Somporn.
Yeah, hello, good afternoon, everybody. Yeah, thank you
Good
very much.
afternoon.
Yeah,
How are you, Dr. Somporn?
yeah, I am really fine, and I'm really exciting to meet all of you. Yeah.
Okay, glad to have you here, and please allow me to read your CV shortly. So Dr. Somporn accomplished his doctorarium naturalium of applied mathematics at University of Heidelberg, Germany, and also his master of computational science at Chulalongkorn University, Bangkok. And he's now currently work as director of Office of Academic Resources in Prince of Songkla University at Patani campus. And also some of his research and publications includes flood modeling and risk map simulations for Mae Swam Da break in northern Thailand, and also the use of biological resources for an effective, sustainable, and secure utilizations by means of community participations in Patani Bay. Okay, we cannot wait for your lecture, Dr. Somporn. Once again, thank you for being here. And I will continue to read the second speaker, CV, which is we have Dr. Sheeba Cheenoli. Hello, Dr. Sheeba. Are you with us?
Yes.
Okay.
Yeah.
Thank you so much, Dr. Sheeba, for your willingness to be our speakers in the GLS of SDGs. Now, let me introduce you and reading your CV. So, Dr. Sheeba accomplished his Doctor of Philosophy at Science in University of Malaya, Malaysia, and also her Master of Technology at Cochin University of Science and Technology in India. And uh, some of her achievements or co-curricular activities include principal investigator or PI at observational and numerical study of meteorological characteristic over Antarctic Peninsula, and also consultant for high density air quality monitoring in the Klang Valley, Malaysia. And her research and publications include linkage between climate change and coastal tourism, bibliometric analysis, and also temperature and precipitation during winter in Nye, Alasan, Swartberg, and possibly tropical linkage. So Dr. Sheeba will deliver her lecture related to SDGs number 13. Okay, thank you so much once again, Dr. Sheeba, for being here. And we will continue to introduce our third speaker. Last but certainly not least, the third speaker is Professor Subimal Ghosh from Indian Institute of Technology, Bombay. So hello, Prof. Subimal.
Hello, everybody. I am Tanvi from Office of International Relations, IIT Bombay. I'm speaking on behalf of Professor Subimal Ghosh. Actually, he's into a meeting which turned out to be a little longer than expected, but he'll be joining us around 2:30. And thank you. We are very happy to be part of this guest lecture series, ITS.
Thank you
Thank
so
you so
much, Ms.
Yeah.
Tanvi Mehta from IIT Bombay. Cannot wait to hear the lecture from Professor Subimal. Okay, so there are our respected lecturer. our speaker for today's meeting. So I will remind again for participant, if you have any questions that may be along the event tickles you, please do not hesitate to drop in this forums, or you can write down your questions through the link that has been sent to the Zoom chat box. And later we will discuss it in the Q&A sessions. And yeah, please enjoy our lectures in this evening. So without further ado, I will invite Dr. Somporn Chuai-Aree from Prince of Songkla University uh, to present a lecture about SDGs number 7 entitled Affordable and Clean Energy in Household and Community Level. So the time is yours, Dr. Somporn.
Yeah, okay. Thank you very much. Firstly, I'm very happy to be here today. And actually, we have a chance last time that last year, we have also have a chance to talk together in the ALN network. Okay, let me share my slide. Maybe could you please allow me to share my slide? I can really. Okay, then I show you some slides of mine. Actually, where I am at the moment, I am really here, yeah, close to the Patani Bay. Okay, it's come from this part of the earth. This part right now, I am really here. This one, okay. And okay, let me show you for my slides. Okay, again, thank you again for invitation. And today I would like to talk about the SDG number 7. Yeah, it's but in the level of the household and community level. Okay, that is I think it would be nice to start from the family. Okay. Next, I would like to relate from last year, and last year is like last year and yesterday of last year, something like that. Okay, that I have presented for the sustainable household and community in the COVID era at that time. And then I think that time that is it seemed like some people invited give the information to you, and then the time for me to come here again today. Okay, and it is actually for my research. It's related about the simulation, computer simulation, mathematical modeling, about the natural disaster management. And also some part is in agriculture, and some part in like a tsunami or kind of tropical storm and the cloud, something like that. And then a part of research field is like in the part of the modeling simulation, in the plant growth or in agriculture, in the meteorological data or image processing, thing like that. Okay, this is like a part of the agricultural modeling, a part of the plant modeling, yeah. And also the part of natural disaster management is flooding, coastal erosion, and kind of storm and tsunami and so on. And about related to the medicine, it's like a simulation of the neural structure using L system, thing like that, or blood flow, thing like that. And okay, last year I just say like how to bring science to the community. So this is just the idea. It's like I just make like an abbreviation of each letter. Okay, in order to play that is about the science. I want to bring science to the community. But this year I think it's a good chance to move again a bit to the lower level in order to do part of the practical part. Okay. Actually, this is
คือพระองค์ท่านเนี่ยมีความเพียรมากมีการต่อสู้ต่อสิ่งหลายๆอย่างซึ่งผมคิดว่าตรงนี้มันเข้าไปอยู่ในจิตวิญญาณของเราแต่ว่าชาวบ้านก็ต้องร่วมกันคิดทำนำพาแล้วก็วนกันแบบนี้เพื่อที่จะให้แนวคิดของพระองค์ท่านเนี่ยจะเดินต่อไปด้วยกัน
Maybe I think voice is not important. I just want to show you that it is like with the time when I go to the village or to the community in order to promote about the energy, affordable energy and clean energy. I mean, this is very, very important for the households in order to support about the natural disaster management in the local level and regional level. It depends on the what kind of the problem. And we would like to do like to make like a car, my car, in order to make it like to be the learning, the movable learning unit, thing like that. Okay. And we would like to think about if we would like to supply for the household, what should we prepare? The first one is like electricity. The second one, it should be water supply. And the third one, it should be like the food security, like that. And after that, we also can also let them to provide about the biomass, or biodiesel. It is also the idea in order to let the people understand, in order to try to make the household level to be SDG, at least a bit in the number 7, SDG number 7. Yeah. And then we just make a house to be the school. I mean, it is also the part of the school in order to prepare everything, and also about the knowledge and also the learning unit. That is very important for the household level. Okay. And that is a part of this of my objective that I go to the village or community. Okay. Yeah. And it is like I just say something like it is related to our King Rama 9. Okay. That is should be enough for this part. Okay. And then I just want to tell you that what is possible for the affordable and clean energy in the household level and also the community level. I think the first one it should be like solar energy, hydro energy, wind energy, wave energy, biomass, biogas, and biodiesel. And this one is like the integration of the available source of energy or energy source that we can also apply for our SDG number 7. Okay, that is very important to think, but I don't think for the part of the national level. Firstly, because I want to just start from the bottom up level. I mean, from the household level and up to the village, up to the community. Okay, like that. And after this, I will show you that is what I have done and what should we prepare, not only for Thailand, but can be everywhere. I mean, on the earth surface, that we can do together and try to improve together. And this is like my house. I mean, inside the university, we also try to install for the part of the solar panel. And this one, it can also supply for a whole house. And if we have a sunlight for a whole day, we can supply it 100% for a whole day, 24 hours, supplied powered by solar cell. For example, this is just the example. Even one solar energy. Okay. And after that, before going to the detail, I want you to see what is the other doing. Okay, for example, Germany, they also install a lot of solar cell, I mean, on the roof, and also even some part like the size of the road, thing like that. Or India, they also like today we also have the group from India. So this is like they install on the water canal like this, and this, I think it's very good idea, I think, to do this. And maybe they can also supply water to the other, like the field around this zone, also possible. And in Japan, for example, they also in the on the surface, they just grow like a vegetable, and after that they also have the solar cell, okay, to power it. I mean, also like you can sell it like that. Okay, it is also the idea. And for example, this is in Myanmar. In Myanmar, normally when during the summertime, I mean, the river also in the Irrawaddy River, they also have the less water. So and all the people have to go to the middle of the river and then try to carry from each person back to the house. And then they also think and rethink again. It's like okay, it's possible to start by 4 solar panel with the 1 solar pump, and also put something like with the pipe about the 1 kilometers, and also all the people will get the water at the temple, for example. This also can reduce the distance for the people. And this is my vehicle that I try to improve it in order to make it as an movable energy system. When I go to the village, I don't need to ask for the energy from the people, but I can supply myself from the car, okay, without burning the diesel, okay, for example. And if we look to our country level, we think about the radiation map, for example, for a whole year, like that average value. And if we think about for each month, we will get something like that. If we try to make it like this, I mean, like for a whole year for each month, and then we think about what is the consumption for a whole year, and then we will see, like, even this part, you see, like we need also the to consume a lot of energy in the summer time, and then it reduce at the rainy time, like that. But it is possible to like use the solar cell in order to reduce this one that we also try to use during the summer all the time. It's possible to reduce something like this in the future. Maybe we can also supply this part by the solar cell, okay? That is idea. And then I think, okay, maybe we need to think about, is it possible to use solar cell? And then I try to install for 5 stations. And then we also get really the same idea of this one. Like you see this one, and it's related to what we also have to consume the energy in the country level, national level. And then maybe this one, it also can help us to reduce this part in the future. We hope like possible to reduce in the part of SDG 7, okay? And if we come to the family level and then think about what is your land, and think about your land, your area around your house, and what you want to prepare for. I mean, to be the SDG, I mean, SDG any, okay, let's say SDG star, not only the 7, but you can also integrate from each part together with the other. Okay, for example, like we have like rubber plantation, the forest zone over there, rubber plantation over there, little pond here, and also we have the like a 1 house 5 hope, like I showed you already in the video. And also this is the water supply, we have the rice field, we have the food security here, integrate all things together. And then even the fertilizer, it also will flow to this part, and then water will flow to this, and also flow to the rice field. It is like you have to plan for the in the household level, okay? It's important one. And then if we plan like that, we think about what should we have, and then we do it, and we start to do it from my home, okay? I just invest myself, I mean, invest from my budget, from my pocket money in order to start. It is possible or not to use this. And then after that, we know that also possible to use even any kind of energy that we can get from the nature, okay? From the sunlight, from the wind, from the water, from the wood, or from from the trade, and so on, okay? This is like show, share, care, learn together. We can think like, okay, 1 household for 5 faculty. We think about in the household, it's like a university for 5 faculties. The first one, it should be faculty of electricity or engineer, for example. It just come from by the solar cell or any different sources of the, from the SDG 7, okay? And then maybe not only for that, but it can be like floating one, or even like on the roof, and so on, floating solar like that. And also the kids can also come to learn together in order to let them
โอเค1 2 3ถอยออก wow.
In order to let them learn what is going on. If they try to practice somehow, they understand from they are too young, okay, and then after that they can use and understand what should they
หนึ่
prepare for
ง
their
สอ
future.
ง สาม
Okay, it's okay, and this is like the part of the water pump. The water pump is also allow you to not to connect to the AC, but connect to directly from the solar panel, and you can also really use it for a whole day. It depends on how much water you need, and plan for the planting, for the watering your vegetable and so on, or pump up to the tank, and then you can supply during the night time. You plan how many liter for per night that you need, things like that. You plan in advance and make everything completely during the daytime, and after that you will try to improve it. Okay, that is also the idea, and it is also another type of the like a hub motor. Okay, like the hub motor from the bike or e-bike. Okay, you can also apply for this water pump also. And the second faculty, like faculty of irrigation, like you need to manage about the water. It's very important one. Water is life. Then maybe you also need to think of how to manage the water from different sources. So then maybe you need the water pump, in order to get the water ready to use, right? Ready to use for during the night time or any time. And you can see like directly from the solar cell, put directly to the DC motor, and you can also you don't need to make to prepare for the long line like before anymore from the AC source line. Okay, it is like we went to the village in order to prepare for the water supply for the school. Okay, then we can reduce from the 6 horsepower to be only 1 horsepower. We reduce like a 6 times or 5 times from the original way that they prepare. Okay, then we can also even like to reduce even the noise, the sound of the water pump and so on. Yeah, it is maybe we can look in the deep detail later. And this is also another school that they also try to pump up the water to the tank, and also they have the watering here to their vegetable field. Okay, and this is like a solar cell that they can also do the tracking. Okay, solar tracking during the sunlight. Okay, and it is like water pump. Okay, from different type of the water pump, and also
ปั๊ม3 แรง 3 นิ้ว
by the
นะคะ
solar cell.
ทดสอบระบบตอนที่ยังไม่มีแดดนะคะ ใช้แผงโซ
And
ลาร์เซล
actually
ล์
we also
330 วัตต์
train
10 แผงนะคะ
to the people who are interested in
ตอนนี้ไม่มีแดดเลยนะคะ
to the solar cell or to the SDG 7. Okay, I go next. Okay, maybe. And the faculty, the third faculty, like the faculty of agriculture and fishery, it is the part of food security. You have to prepare like the place that you can grow something, grow your food and so on. Then it is very important for planning during the natural disaster. Can be anything can be occur. Okay, even earthquake or tsunami or heavy rainfall and so on. The fourth faculty is the faculty of bioenergy, like biogas, biomass, and biodiesel. You can also use the rest of things in order to change it to energy, and can be supplied for car or for the kitchen and so on. And this is the example of the biogas that I also did during my time in my hometown. Okay, and this is also I just show the plan for the people, and then the people can also do themselves from this system. I mean, they can also supply the biogas in the kitchen. Okay, and the fifth faculty, like the faculty of education, is like the learning unit at home. Okay, people can understand. I mean, the member in the family can understand, and the neighbor also come to learn together, and it is also very nice, I think, to have another one. And then if we integrate together, it like we can also put like a SDG, maybe not only solar cell, but also the wind turbine or the hydro energy or other sources of the energy. Okay, And after that, we think, okay, university is everywhere. Then because we can go to the village, we can also upgrade or upskill to the people. I mean, like upgrade the SDG 7 to the people who are interested in order to prepare themselves for the natural disaster preparation and so on. And that is the time that we went to the village. And after that, we make the program namely like a solar sign program in order to train people. Okay, for the household, one household for 5 faculty, the off-grid, on-grid, hybrid system, the high voltage system, solarized machine, water pump, and biogas, biomass, biodiesel, and also even to use the alternator like that. And after that, we also make like to show like a learning station of the at the library of the university in order to show them that if we would like to make it like a solar tracking system and with many bigger size, how can we do? Yeah, and then we can also give the energy to the rice machine. Okay, example. Okay, maybe see another direction. It is like we have 2 axes, the east, west, and north-south direction. Okay, it can also rotate in the different direction. Okay, and another one is like this one. I mean, after my course, I mean, if some student or the people would like to learn, I mean, you can also contact me in order to train like a course, and it maybe it's also possible to do together. We also like put the solar panel also on the car. This is the car of my wife in order to prepare that. Okay, it's also suitable to do for the car. I mean, this is also possible, and we can reduce the diesel consumption, the fuel consumption also. And it is like in Pattani, close to the bay, we have like a wind turbine like that. Okay, this is like a go to the village. You see, I really like this one because the kids and the people in a different age can also learn together when we go to when we bring the knowledge to the society, to the community. And it is after that we become like a solar man network in order to let people who are using the solar cell and plot the place mark together, and it become shape of Thailand. And I think in the future Indonesia also have many things. And this is also we have like the point of the people, the participants, that they came to our library in order to learn about the solar cell and training for 2 days. Yeah. And I think this is some part of my job. I can also, I don't know that it still have time or not. I make to skip of the thank you. And if I still have time, I can show some part more. Okay. And this is the library. Actually, the library we start by the 34 kilowatt installation, and we can reduce like 70,000 baht per month. And now we have done already for 5 years. We still have about now is about 8 months, and then we will completely return. Okay, after that it is the benefit of our system. Yeah, and this is for the rice machine that we can also use the solar cell to supply for the rice machine, and then you can also supply by solar cell. Okay, I mean you have to analyze in your region that is what kind of energy that is available for SDG 7, and then we try to improve it. Like a solar, it can be solar off grid and something like this. Okay, solar cell, you have a solar charger, you have battery, you have the load or the inverter like that. This is off grid solar. It can be installed anywhere. Okay, on grid solar you can install with the grid line. Okay, and this is just the example one. Okay, you can also connect to your house directly, but you have to have the main supply from the grid. Okay, and the hybrid solar system, this one can be off grid or on grid also. You can set up like computer, okay? You have battery, you have solar cell, you have the grid line, and you have the load, and then you can also set up for the SBU system, and even the solar high voltage DC. This one is very simple because you have like for example, solar panels. You make it series for the 8 solar panel or 4 solar panel together, and then you have the positive and negative. You put together with here, okay? One side is the negative, another side positive from the solar panel. Then you will get directly the heat from this one, okay? And then you can cook, you can do during the daytime. It's very nice because you don't need to have the inverter and so on. You can also apply for any kind of carrier they use during the daytime about the heat, or even to reduce the heat under the roof. It's also possible to use the fan like this to connect like that, and it's very, very easy, I mean, to make it. And even the bill, it can reduce something like this. This is my house. Actually, at the first part, you don't need to put solar cell at the beginning. Maybe you just save it first, okay? Then you can reduce from some amount of money, reduce to here, and then you can add solar cell to your system. You don't need to add at the beginning too big, okay? You can add like how much money that you can invest at the beginning, and then when you gain the happiness from your action, then you can also add the money more and more, and in order to increase your happiness, thing like that. And it later on it become to be zero somehow. I mean, maybe zero consumption from the grid line, or 0 baht, or zero cost, thing like that. It depends on what you want to optimize. And this one is like the house that I told you, okay? And another part also, even the shop, and also the mart, that they can also install the solar cell, or even the petrol station, the hospital, the school, or even the provincial office. So they can do it like that. Even the community and so on, the classroom, and we go anywhere, and we can do supply anything. I mean, this is also the part of my talk, and I think it should be okay. And then maybe you can really ask some question, okay? I don't know, I still have time or not. Please tell me.
Yeah, I'm sorry that your time has end.
Yeah.
Dr. Somporn, however, we still will discuss further in the Q&A sessions later. Thank you so much for such an eye-opening lecture about your effort to achieve affordable and clean energy in your home country, Thailand. And it is really inspiring, and we cannot wait to have a discussions with you later in the Q&A sessions. And for participants, if you have any questions for Dr. Somporn, don't forget to drop your questions through the link in the chat box, okay? And we are now proceed to the next speaker. I will invite Dr. Sheeba Cheenoli from University of Malaya to deliver her presentations entitled Unbundling Climate Crisis and Climate Actions. So please, Dr. Sheeba, the time is yours. Thank you.
Very good afternoon, everyone. Here we are having a very heavy rainfall, right? So there might be, some, you can hear some thunder sound in between. Sorry about that. Actually, I cannot do anything about it, right? All right. So I guess you all can see the slides and hear me.
Yes, we can hear you clearly and see your slide. Thank you, Dr. Sheeba.
And thank you for the introduction and for inviting me to this guest lecture series on sustainable development goals. As as you heard from the moderator, my name is Sheeba Cheenoli, and I'm a senior lecturer at the Department of Geography. Also, I'm a research associate at the National Antarctic Research Center, as well as Institute of Ocean and Earth Sciences. So I have been conducting research on atmospheric dynamic and climate of the tropical as well as polar region. One of my new projects is to investigate how the polar region influence the weather and climate of the equatorial region and vice versa. But today I'll be sharing not very related to my research, but mostly about the climate action and also about a fun project that we have done with another few educators. That is about the climate action project, right? So here's the outline of my talk. Firstly, I would like to take you through the basics of climate science to inspire you to take action, right? So that is the SDG 13, right? So what are the state of knowledge on climate change, and what is the concept of 1.5 degree warming? And I would also look into why it is climate crisis now, and what is meant by climate tipping point, and some information on the regional context. Finally, I will discuss. So finally, I will be discussing about the how we can make climate action personal, right? So here you can learn about our new module on climate change, which is a bite-sized climate action module. It is funded by British High Commission in Malaysia and also ECONI, right? So though it is personalized for Malaysian youth, I guess there will be more relevant information that you also can learn, right? Okay, so before we talk about climate change, we can discuss the difference between weather, climate, and climate variability. So it's a common source of confusion regarding the climate change. What is the difference between weather and climate, right? So the atmospheric condition that we are experiencing right now, that is we call as the weather, right? So if I look at outside now, I can see it is really heavy rain. So that is the weather, okay? So it might be sunny, cloudy, or rainy weather at a particular place. So the weather is what the atmosphere does in the short term, right? So our day-to-day weather can be very chaotic. Within the few minutes, you can see changes in the weather. But climate, on the other hand, it's based on the definition of a World Meteorological Organization. It's a statistical composite of weather condition for a region over a long period of time, maybe around 20 to 30 years, right? So in other words, climate is how the atmosphere behaves over a relatively longer period. So drastic change in the weather is usually not a concern, right? But when you have a small change in the climate, then that can impact you and also the environment that you are in. Okay, so let's look at what is the climate variability, right? So, and what is the difference between climate variability and climate change? Climate variability refers to the natural variation in the climate that occurs over months to decades, right? El Nino is a good example for climate variability, natural climate variability. There will be changes in the temperature, rain, and wind pattern in many regions over about 2 to 7 years. Okay, so this is a good example of natural climate variability, and also called natural variability. So the climate change, on the other hand, is systematic change in the long-term state of atmosphere over multiple decades or longer than that, right? So now we can look at what is meant by climate change. So you can find various sources of definition such as United Nations Framework Convention on Climate Change, UNFCCC, right? And also from Intergovernmental Panel on Climate Change. According to UNFCCC, a change of climate, which is attributed directly or indirectly to human activity. So UNFCCC is pointing towards the anthropogenic activity, right, which alters the composition of the global atmosphere, which is in turn, which can be in addition to the climate variability observed over a comparable time period. Whereas IPCC defined climate change as a statistically significant variation, either in the mean state of the climate or in its variability, and it should be in a longer period, right, extended period, typically decades or longer than that, right? So before we go into the various details of the situation, let us look at how we get there, right? What we have done to get into the moment of climate change. And it is always good to look at the historical perspective. So whenever we think about the human history, we have to go back a long, long time, right? So when our ancestors first walked into the planet millions of years ago, at the time itself, we started to change, right? They started to change the environment they lived in. But that time, it was very local, right? So those changes were very local, or they changed just the surrounding area that they lived. But something really changed in the last century, especially the last 50 years, right? So recently, we began to change our entire planet at once in several different ways. This is because there are a lot of people now on the planet, and also we become an urban species. So with over half of the people on the earth living in the city, right? And there's also, this was actually never happened before in our history, in human history, right? And we also formed global economy, which is powered by technology and international trade, which is going very faster than ever, right? So in summary, during last 50 years, there have been a doubling of global population, economy, 3 times more food need, twice as much as the water, and the need for water or usage of water, and burning a fossil fuel 3 times more than ever, right? Or when we compare that to 1970s or before that. Therefore, last 50 years, we have changed more than the entire sum of human history. So if you have a look at these graphs here, so you can see how the global population has increased, after the, around 1900. It's increasing very steeply, right? The graph is very steep. And at the same time, how is the urban population increasing and how our GDP has changed, right? So some of these changes are very obvious. We can see and also we can see how we are destroying our planet, right? So, for example, we can look at the Earth from the outer space using satellite image. So what you can see here is the forest. So it is a pretty remote part of Amazon in Bolivia during 1970s, right? So if you look at carefully, you can see some dirt road, right? So that is the first forest clearing in 1970s, right? So the next photo on the right-hand side shows the same place after 25 years. So after 25 years, the whole area has been transformed into soybean field, right? So these soybeans are being shipped to China to be used as animal feed, especially to feed the pigs, right? So this is just one example of how global economy is clearing the remote part of the world, and how the global economy is linking from one part of the world to another part, right? So this is happening everywhere. And 30% of our tropical forest has been lost because of this agriculture and other land use changes, right? Now we can look at another satellite picture. And we also change, our land area for agriculture, right? So it is the largest ecosystem now, right? It was a small scale activity earlier, Now it is a global force. So again, we can look at the satellite image. So the green color here is, the area that is covered by agricultural land. And orange color shows the location of farm animals. So when you see the green color, you might think that it's all good, right? But it is not true. This image shows the most significant ecosystem in the entire world, that is agriculture, right? That means we are using fertilizers, manures, and that these activities would end up with adding more nitrogen oxides in the atmosphere, right? And which is the greenhouse gas, and this can change the composition of the atmosphere. We remember the definition for climate change, right? So we are changing the composition of the atmosphere and thereby increasing the warming in the planet, right? So this is another example how we change the water resources, right? So we are one of the thirstiest animals on this planet. We use water for agriculture, industry, electricity generation, construction, household use, drinking, right? There's so many things that we are using water for, right? So we are changing our water resources in various ways. So this is an example. The image on the right is taken by satellite image around 1970s. I mean, the left part right here. And this is one of the inland sea called the Aral Sea. The Aral Sea is fed by several rivers nearby, which is flowing into the sea, right? Soviet Russia at that time decided to divert these rivers from around the area to the middle of the desert to irrigate cotton plantation, right? So this it cut down all the water that is going into the Aral Sea, and this made the Aral Sea to dry up. So you can see at present what happened, right? So all the ecosystem related to this Aral Sea also lost because of that, right? So the water resources are collapsing everywhere. So this is happening in Australia, California, Africa, China, right? Everywhere, in Malaysia too, right? So, so far we talk about the visible changes that we made in the environment on large scale, right? And there are some changes that are not visible, but it is also hazardous. We are burning fossil fuels more than ever in the history: coal, natural gases, for electricity, for transportation and industry and everything, right? So this results in the emission of carbon dioxide and methane and other gases into the atmosphere. And you can see here from the Industrial Revolution, the amount of carbon dioxide, how the amount of carbon dioxide is increasing, right? It was flat earlier and it was increasing after that, right? So what does that mean? Again, the composition of the atmosphere is changing. That means we can expect climate change, right? So the amount of greenhouse gases called the, it is increasing, and it is capable of trapping heat energy in the atmosphere and thus increasing the temperature of our environment, right? And another thing that you can see here is the temperature, how the temperature is increasing, right? If you look at both how both these changes are, you can see a very a high correlation between these two, right? Here you can see, right? So I'm sure that you heard a lot about the burning of fossil fuel, burning of natural gases, coal, etc., for various reasons, right? So if you look at this graph here, you can see the major part of the emission of greenhouse gases are coming from the electricity production, right? And then we have food and agriculture, land use, industry and transportation, buildings, and others are contributing, other rest of the emissions, right? So, so burning of fossil fuel is causing tremendous amount of carbon dioxide increase in the atmosphere. Around 62% of warming that we see in the planet is contributed by the burning of the fossil fuels, right? The fossil fuel cause more than half of the climate change, right? But this is not all. The carbon dioxide are also produced. You can see the green area here, right? Produced by deforestation, land use, etc. Right? Then there is some other gases also, right? That is methane. Methane is produced by a whole bunch of different things, but the two big sources are agriculture and industry, right? Methane emission is also caused by farm animals such as cattle, right? So, and then we have got this stuff called the nitrous oxide, right? Which a lot of people don't even think about it, but it is also a big part of our climate change equation. Right, the nitrous oxide also coming from industry, agriculture, etc. Then we have, the F gases or fluorocarbons, which are coming from the refrigerant, etc. Right. So these are the sources of greenhouse gases. So here again we can look at the emission sources and natural sink. Right. On the left hand side, you can see all the current sources. Right. Of greenhouse gases, and the right hand side you can see what are the current sink. Sink means what can absorb, right? All this carbon dioxide that is coming from, right? Right now our source of pollution is much bigger than what nature can take out. That is why the level of the greenhouse gases is going up. So if you look at here, out of 100%, 41% of pollution is absorbed by our current sinks here, right? But what if we reduce our pollution, right? What if we brought it down as half, or then maybe the nature could kind of keep up with it and pull as much as pollution out of the atmosphere that we are putting in, right? So if that were to happen, we should stabilize the carbon dioxide level, right? But we can go further than that, actually reduce the pollution down to zero, right? So nature can pull more carbon and other stuff out of the atmosphere by, land sinks, which is porous, and ocean, right? The coastal ocean, it can absorb carbon dioxide also. Right, so that will help reducing the global warming, right? And so the balance between the source and sink is what will determine the future of our planet. So future is not all gloomy and dark. We have hope, and this is the basis of popular zero emission concept, right? And you might have heard about this global warming of 1.5 degree, right? So why 1.5 degrees is so important for us? We are living in a tropical country, right? So if the increase in a degree or two does not make any difference for us, right? But here we are talking about the global average increase of mean temperature, not the temperature at any particular place. That means we average the temperature from different regions. So this also means that there can be places that the temperature is increasing more than 1.5 degree, right? For example, some part of the polar region, which is, heating up very rapidly, right? So the average temperature difference between the Little Ice Age and the pre-industrial time, it is just 0.6 degrees. So which shows that small changes in the average temperature can make a lot of differences, right? So this is the global warming of 1.5 degree report that is released by IPCC a couple of years before, right? So the climate change, you can see, is already affecting the people, ecosystem, and livelihood around the world is already affected. Limiting the global warming to 1.5 degree is not impossible, but we need to take drastic changes. We need to have lifestyle changes, and also, we need to cut down the carbon dioxide a lot, right? And there are clear benefits to keeping up 1.5 degree rather than the 2 degree or higher than that, right? So limiting 1.5 degree can go hand in hand with achieving other SDG goals also. And this gives you the changes of, the impacts of, the observed impacts in the natural and human system. We already see changes in the temperature and precipitation pattern, sea level rise, rise in the extreme events, right? And we already know that there is biodiversity loss and changes in the pattern of migratory fish and coral bleaching, right? We already have climate refugees, and there will be impact, or there are already impact on health because of temperature changes, heat stress, and vectors, number of vectors like mosquitoes are increasing, and that will cause more infectious diseases, etc., because of the climate change, right? So let us look at what will happen if we have 1.5 degree, more than 1.5 degree, or if we overshoot the 1.5 degree, right? So there will be 2.6 or around 3 times more people exposed to extreme heat, and will be a lot of the heat related health issues, and there will be 6 centimeter higher sea level rise, and this can cause some of our metro cities like Jakarta, Shanghai to go underwater, right? And there will be 2.3 times of reduction in the crops, right? When the temperature increases, the crop productivity can decrease, and 2 times more animals can, they can lose their range, right? And 29% more coral reef can get bleached, and this coral reef is also connected to the marine fishery resources. So we can also expect decrease in the marine resources if we overshoot to 1.5 degree. Right. So here you can see the cover picture of Time magazine. This is in 2006. Then we have 2000, if I'm not mistaken, it's 2020, and the final one is 2021, right? So this shows, this shows that there is emergency, climate emergency. You can see the first one say, be worried, be very worried, right? And if you are the one who always follow the, the climate related news from the from the articles, research articles or media, you might have noted climate scientists and organization from UN and meteorological offices all over the world. They are changing the terminology, right? And they are using stronger language to describe the situation we are in, right? So now we are using climate crisis instead of climate, climate change and climate emergency. So this is to communicate reader about the urgency accurately and describes the environmental concern that we are facing. Okay, so there is another concept called climate tipping point, right? Or climate tipping elements. So climate tipping point is another concept to understand the climate emergency. So tipping point is the point at which if there is small change, it can become significant enough to cause a larger catastrophe, or more critical change that can be abrupt, irreversible, and it lead to cascading effects, right? Actually, Intergovernmental Panel on Climate Change, they introduced the idea of tipping point 2 decades ago, right? But at that time, the tipping point in the climate system were considered as, only if the global warming exceeds 5 degrees above the pre-industrial levels, right? But most of the recent IPCC special reports suggest that the tipping points could be exceeded even 1 to 2 degree warming, right? So in other words, we have to limit the global warming to 1.5 degree, and this requires an emergency response. Right. So this the major group of tipping elements are ice bodies, that is cryosphere, circulation of the ocean, as well as atmosphere and large-scale ecosystem, that is biosphere and biospheric components, right? So these are the major tipping elements in the climate. And this, the risk of the tipping also changes with the warming. So one point, if the temperature is between 1 to 3 degrees of warming, so it includes several cryospheric components. But if it is more than that, then there will be the components that will be affected by will be the boreal forest, jet stream, El Nino southern oscillation, thermohaline circulation, etc. Right. So we can see there is also interaction between this tipping element, like through oceanic and atmospheric circulation and through feedbacks, and which increase, and there is increase in the greenhouse gas levels and global temperature, right? And alternatively, strong cloud feedbacks could cause global tipping point, right? For example, Arctic sea ice loss is amplifying the regional warming, right? And Arctic warming and Greenland melting can drive a lot of fresh water into the North Atlantic Ocean, right? And it could, contribute a 15% slowdown in the Atlantic meridional overturning circulation, which is a key part of global heat transport by the ocean. So you can see the climate system is very complex. So when you change one part, or when you add, more warming, what we can expect in the future is very unsure, right? Because it's a very complex system. So we can look at some, regional context about the climate action and also climate change. Right. So if you look at the emission from East Asia and Pacific, we are not the highest, right? But if you look at the ASEAN, right, the emissions from the ASEAN, greenhouse gas emission from the ASEAN, actually we are the highest, and in the top 3, and also it is increasing. And another thing is, in case of Malaysia contribute 0.7% of global greenhouse gas emission, right? But our population is 0.4% of global population. So you can see how much, the carbon footprint each of us have, right? So what is our view on climate change? So this is a survey result, and majority of Malaysians think that climate change is a serious threat, and almost none of them believe that climate change is a fog, or there is no climate change skeptics, right? You can see for Malaysia, there is no red color here, right? But there are people, in ASEAN region still believe that there is no scientific base of, there is no scientific basis for climate change, right? So this is the situation on your view on climate change. Right. So this gives an idea of how vulnerable are we, right? Recently, our Minister of Environment and Water said that Malaysia is not categorized as country vulnerable to climate change. He was explaining our exclusion from US Leader Summit on Climate Change 21, right? But if you see a report that is issued by Swiss-Aree Institute, and it places Malaysia 47 out of 48 countries, right? So second from last. And also our adaptive capacity is very low. So this is the vulnerability because of the climate change that we can expect to see, right? And there is another survey, and level of urgency is there, right? Among our youth, with a great majority of them reporting having directly felt the climate change effects. You can see the under 20, right? There is a lot of people here, more than 50% people here. They are saying that they join climate change movement groups, and they attend some seminars on the environment, etc. Right? But their behavior varies. 50% of the survey response are only under 21 join climate change movements and attend seminar, but 24% of between 21 and 35 also, right? So evidently, there is a growth in the teenage climate activism. It might be catalyzed by, Greta Thunberg's Friday for Future. And this has not left Southeast Asia untouched. So among the participants in climate strikes rallies from Indonesia, Malaysia, Myanmar, Philippines, Singapore, etc. in 2019, younger faces were prominently featured. So that's what we wanted, right? So the youth is the voice of tomorrow. So they have to know climate change as a serious problem, and we have to act on the behalf of it, right? So this is the NDC, the Malaysia recently submitted, all good. But you can see, because we are not relying on the international assistance, but only one, we are the only one, still depending on the intensity and not the amount of the climate, what we call the greenhouse gases that we are emitting, right? So Malaysian have, this is the another survey, right? So you can see Malaysians have low confidence in government climate policies and low, and also it is lowest in the ASEAN region, followed by Brunei and Thailand, right? The contrast to the sense of urgency, which is highest among the ASEAN region, right? So let me briefly explain and take you through our bite-sized climate action module. Bite-sized climate action module is a series of fun and flexible short online module to inspire Malaysian youth to take action for climate, right? So the content of the module has been adopted as a part of climate action elective for our students, undergrad students from University Malaya and also University Nottingham, Malaysia, right? So this project has been carried out by a group of educators, both from University Malaya and also from University Nottingham, Malaysia, right? So bite-size means it is, these modules are short, it is focused, and it is based on the single topic or the single problem, right? So there are standalone modules, 6 standalone modules, which is tailored for Malaysian youth, but I think it's applicable for Southeast Asia, right? And it is very fun and flexible contents. We even have TikToks that is created by our content creators. There are students, right? And podcast and infographic, right? And each module, there will be simple climate action that you can incorporate with your everyday life. And there is information for everyone, right? From the climate newbies until the climate experts. So you can go into, this website and see if you type Climate Act, bite-sized Climate Act. I think I forget to put the website web address here, right? So this is our web page, and there is global warming basics, right? Here it consists of 3 videos from the project members, and we have 6 modules. Our modules you can see here, right? So we have 6 modules, and also we have for educators. That means if somebody wanted to adopt this as the resources for their existing class to add to the existing curriculum, there are suggestions how can you use it from starting from the school level until the undergrads level. Right, so these are the basics, climate science 101. Right, so here there are 3 videos. The first is by me and another from Dr. Matthew Ashfold, right? So me and Dr. Matthew Ashfold, we are atmospheric scientists. We work on the climate and weather, right? And we have another one by the Dr. Helena Murky. She's from University Malaya, and she's a political scientist, and her topic is on global change, global climate change governance framework, right? So this is just a guideline how to use the website, right? So you can first take the pre-module quiz to see how much you already know. Then you can go into the modules, right? So each module consists of video of basic science explaining, and also the reason that why you have to take the climate action for related to that module, right? And there is infographics, podcast, and also TikTok, right? Then after that, you can take the post-module quiz to see how much you have improved, right? Nobody is going to grade with this quizzes, only you can see how much you grade, how much you got, right? Then if you wanted to know more, then you can go into the reading list and the resources here, right? Then we always suggest the students to carry out one climate action, whatever is doable for you, whatever it is inspired, right? Then tag us in the social media, right? So we have Instagram, we have Facebook, we have Twitter. So you can tag us in bite-sized climate action. There are so many students, not only from University Malaya or University Nottingham, Malaysia. There are so many students, they used to tag us in the social media, right? So we have this tagline for climate action: avoid. Avoid means avoid unnecessary consumption and emission, right? And improve and shift towards more climate friendly options, and improve the carbon efficiency of your actions, right? So these actions that you can take. And our 6 modules consist of electricity, food, trash, transport, forest, and change. And one of the famous module is food. Malaysia is all about food, right? So some students are surprised to see the choice of our food can relate to climate change, also can relate to the amount of greenhouse gas emission that we are causing, or our it can relate to our carbon footage, right? So we have the podcast. This is an example to show how an individual module look like. That is the next one. But we have okay. All right, so we have you can take the pre-module quiz. This is an example to show how the module looks like. This is electricity module, right? And then you can watch the video, and after that you can listen to the podcast. Podcast will be usually done by some prominent social or influential people in the area that is related to that module. Then we have, TikTok that will be to give an idea how you can take some action related to that module, right? Then you can take the post module quiz, and there will be, reading list for the newbies or for the climate action enthusiasts or the experts, right? So these are all the modules. I just want to show.
I'm sorry, Dr. Sheeba, I'm afraid that your session has been finished. Would you please wrap up your presentations?
Yes.
Thank you.
Actually, end of the slide.
Okay, thank you.
So that's all from me. Now you understand the situation. So it's your turn to act. Thank you very much.
Thank you very much, Dr. Sheeba, for your inspiring and comprehensive lecture about SDGs number 13. And I believe we have received some of the questions from participants, and see you in a few minutes in the Q&A sessions, Dr. Sheeba. Thank you so much once again. So still in the SDGs 13, we are now inviting Professor Subimal Ghosh from Indian Institute of Technology, Bombay, to deliver a lecture entitled Global and Regional Climate Change, Impacts and Adaptations. So, Professor Subimal Ghosh, the time is yours.
Yeah, thank you. Thank you. Thanks a lot for inviting me. Let me share my slides. I hope this is visible.
It is visible and we can see it. Thank you.
Yeah. Thank you for inviting me. So today I'll be talking more on global and regional climate change. What are the assessments made by IPCC Working Group Assessment Report 6 by Working Group 1, and in what way we can think of certain climate adaptation techniques. So I am from Indian Institute of Technology, Bombay, an institute at in India over Mumbai, and I am currently the convener of interdisciplinary program in climate studies, which is a center that focuses on interdisciplinary programs, and this is the first PhD program on climate change which was set up in this country, and which was set up in 2012, and where we focus on interdisciplinary areas of climate change, starting from climate science to climate adaptation to climate mitigation. And this is an umbrella where faculty members from different departments work together in different interdisciplinary areas. And at the same time, I'm also affiliated with Department of Civil Engineering. Now, of course, there has been a bit of introduction to climate change. So I'll just quickly mention what are the major three pillars of climate change analysis or climate change research. The three pillars are climate science, climate adaptation, and climate mitigation. So let us try to understand what does each of them mean. So when you're talking about climate science, we are essentially talking about the different processes in climate systems and their trajectories. So my previous speaker has already mentioned that there is a strong relationship between different components of the climate system. When you're looking at climate system, it's just not just atmosphere and ocean. Rather, it's atmosphere, it's ocean. So it's essentially atmosphere, biosphere, hydrosphere, and geosphere. The four spheres are involved. And within these four spheres, there are a lot of subcomponents. And all these subcomponents across the sphere boundaries, they are all connected. So it's a huge network. I'd say I look into climate system as a huge network, and each of the links in this network represents a process. It's a very complex process. And climate science really talks about understanding of these processes, and in a different world, in a higher anthropogenic activities, how the processes will change, how the internetwork will change. This is all about climate science. Now coming to climate adaptation, we all know that global warming is taking place. There has been a lot of carbon dioxide emissions. One of the major thing of carbon dioxide is that it has a huge, very long residence time. So let's say tomorrow, if you stop emitting carbon dioxide, let us consider an imaginary situation which may not happen tomorrow, but which will not happen tomorrow, but let us consider this. Even the carbon dioxide, what is present in the atmosphere, that results into the changing patterns of climate with the increase of climate extremes and so on. So these are the situations which is unavoidable, but there are ways to manage these unavoidable situations. Let's say if there are increased number of extreme precipitation, we can improve our forecast system, we can improve our evacuation system, we can improve our drainage system, and so on. So this comes under climate adaptation. Now the third one is climate mitigation. Let us try to understand what does it mean by climate mitigation. Let's say the way we have increased the greenhouse gas emissions, if we continue to increase at the same trend or at the same rate, then what will happen is that after a certain period, we will be in a condition which cannot be managed. And we have to avoid this unmanageable situation through better carbon dioxide absorption and also better controlling the greenhouse gas emissions and developing more green technologies and so on. So this is avoiding the unmanageable, which is climate mitigation. Climate adaptation means managing unavoidables, and climate mitigation means avoiding unmanageables. If you are considering Intergovernmental Panel on Climate Change, they come up with 3 working groups. The first working group is concentrating on climate science. The second working group is on climate adaptation, and the third one is on climate mitigation. Now, we all know that in 2021, we had a major release, which was the 6th assessment report of Working Group 1 was released. Very recently, Working Group 2 report was also released. So I was fortunate, I was kind of fortunate to be one of the lead author of this working group 1 report. I was the lead author of chapter 11, which is focusing on weather and climate extremes. I'll quickly focus on what are the major key messages on what has come from working group 1. So working group 1, if you look into it, there are 3 parts. One is the global part, the global changes, which has been concentrated over first 3-4 chapters. Then there are processes. What are the different climate processes and how are they changing? They are being focused chapter 5 to 9. And then chapter 10 to 12, they are focused on regional impacts. So this is something what is very important. What are the regional changes are taking place and how are you connecting it to impacts and adaptation? So that part has very well come in the regional chapters with a very nice atlas chapter where you can actually see what is happening over different regions. So this is the way the working group 1 report was made. And if you look at working group 1, so there are 234 authors from 65 countries who were involved in writing this report. And the report started with physical meeting. After that, COVID time came, and then there were online meetings. It was a difficult task because it took 3 years to complete the entire task. And so IPCC does not really perform a new research, but rather from assessment report 5 to assessment report 6, whatever newer scientific publications have come, IPCC scientists, the 234 authors have assessed them and then come up with a report. And this report has multiple stages. There are 0 order draft, there are first order draft, there are second order draft, then there are draft for final government distribution, and then final draft. So at different stages, we have received around 78,000 plus reviewers' comments. And each and every comments we have to address and we have to write a response. And at the end of everything, 46 countries finally commented on final government distribution report, and all of them has been addressed. And after that, the report has come. And as you can see, this is our chapter 11 team, and there were representation from different parts of the globe. So let us try to understand what IPCC Assessment Report 6 Working Group 1 has said. This is the first time IPCC has very clearly said that recent changes in the climate are widespread, rapid, intensifying, and unprecedented in thousands of years. So all these 4 terms are very, very strong terms, are very important. The first one is widespread. It is happening all around the globe. It is rapid. It is happening now very fast. My previous speaker has said that it's an emergency. Yes, it's a climate emergency now. It is intensifying. And this is unprecedented. We have never seen this kind of changes over the thousands of years. And these 4 are not really very good sign or very good news for us. Now, if you look into it, you can see that, we are at the level of 1.1 degree centigrade warmer condition compared to the pre-industrial period. And you can see that such a high warming we have never seen over the last 2,000 years. So you can see there is a huge warming that is taking place. But of course, you can ask that you're only talking about 1.1 degree centigrade. Why it is so important? So the answer here this is the mean condition. This does not really talk about extremes. It is just mean observed condition. There are huge spatial variability. That's the first thing. The second important part is that climate is always in a very delicate balance. If you change one variable, it changes this other variable in such a way so to reach equilibrium and so on, to reach a stable condition and so on, and because of which you may expect drastic changes in many other variables, and that's what is happening. And now the second question will come whether human activities has really resulted into this kind of changes or not. So for that part, climate scientists has developed different experimentation with climate models. So the first kind of experimentation, so you can see here, you can see the black line represents the observed condition. Now there are climate models which were run with natural conditions only. That means with natural forcings, solar and volcanic. And if you can see, if you don't add the human contributions or human emissions, then what will happen? It shows a slightly decreasing trend over the recent period. But as soon as you are adding the human component of greenhouse gas emissions, you can see that the climate simulations are actually following the observed condition. That shows that human activities have resulted into the global warming, which we are now seeing. And based on that, the IPCC has said that it is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere has occurred because of this human contributions, which is very important. So it is happening everywhere, and this is because of human contribution. Now, the third thing is that now we cannot say that climate change will happen in future after 100 years and so on. This is something we keep on saying, but it's not correct now. Climate change is already affecting. It has already started affecting us in multiple different ways. We have seen that increased tropical cyclone, increased number of floods, increased number of droughts, and so on. We are seeing this increased number of heat waves. So it has started affecting in multiple different ways. In fact, if you look at what IPCC Working Group 2, it has very clearly said that with the increase of population, we have to feed a lot of people, and to ensure food security, we have to improve our agricultural management practices. But at present, with the agricultural management practices which are being applied, they are found to be not sustainable. With a very high confidence, IPCC Working Group 2 has very recently said that with a very high confidence, it can be said that they are unsustainable to really help the water, to really solve the water security and food security problem. Because with food security, to meet the food security, we need water, and we do not have that much supply of water, availability of water. So in that way, we are actually in a bad trap, and we have to think of certain ways so that we can come out of this. The climate actions are important. So now let us see what exactly is happening. So IPCC has come up, this is for summary for policymakers, very nice figure. If you look into this figure, this is essentially representing the globe. And this is the North America, this is South America, this is the Asian region, this is our South Asia, and this is Southeast Asia. These are the African region, these are the European region, and this is the Australian region. And you can see this is about the heat waves, the hot extremes. You can see that almost everywhere the hot extremes have increased. You can see red means increasing regions, and blue means decrease. There has been no decrease in the heat waves. Almost everywhere the heat extremes have increased. There are a few regions where there is a low agreement or limited data. You can see these are the regions where we have limited data, and these are the regions where we have low agreements. Now the second question will come, has it been contributed because of the human contribution or not? So if you have high confidence, then there are 3 dots. So for South Asia and Southeast Asia, you can see that there are 3 dots. That means this has been happening because of human contributions. The human contributions have resulted the increase in hot extremes over South Asia and Southeast Asia, and there is a very high confidence that heat extremes has increased over this region. Now let us look into the extreme precipitation. Now for extreme precipitation, you can see that more regions have increasing trend, decreasing trend is not there. Extreme precipitation has increased, and there are a lot of regions where we have limited data, because precipitation data is always challenging, when precipitation modeling is also challenging. But if you are considering South Asia and Southeast Asia, you can see that there has been an increasing trend of extreme precipitation. Now, has it happened because of the human contribution? One of the problem is that to measure this kind of thing, we have to run the models. As I've said that, we have to add human contributions and so on. The models are very good for the temperature, but they are not very good for precipitation. It's the same thing like, I just always give this example. Let's say if you are preparing popcorn in a bowl, and if I'll ask you what is the temperature of any point of this bowl, you'll say that it's very hot. But if I'll ask you over the next 10 seconds, over which region the first corn will pop up, you may not be able to tell, because you don't know that where the instability will form, and from there the corn will pop up. Precipitation is also like that. It depends on the instability. So what will happen is that it is very, very uncertain to find out where exactly the extreme precipitation is taking place, and because of which getting a specific causal factor for extreme precipitation is not very easy, and because of which IPCC has said there is low to limited agreement that human contributions have changed. But of course, it shows that there has been an increase in extreme precipitation. Now, if you are considering the drought condition, for drought condition, there are different kinds of drought. There are ecological drought, there are agricultural drought, there are meteorological drought, and so on. Overall, globally, the drought has increased, but for South Asia and Southeast Asia, there are low agreement among literature. So there is not very there is not high increment, because of which we cannot really say it high confidence that it has increased. Now, this is about the 3 major extremes. One is heat waves, one is precipitation extremes, and the third one is drought. Now, let's say if you have to go for future projections, then in what way we can go for future projections? For future projections, we have to run the climate model. So climate model was the previous version. Now we are essentially talking about Earth system models. So when you're talking about climate models, these are actually mammoth models, which considers, let's say, 4,000 partial differential equations which are coupled with each other. And you cannot really run it on a desktop sort of thing. You need a high performance computing facility to run it. It has multiple components. It has oceanic component, it has land components, and so on. And this is a typically, some sort of a coupled climate model. But when it comes to Earth system model, which is much more complicated because we are considering carbon cycle, the vegetation, dynamic vegetation, the more fine, more granular scale anthropogenic emissions, the interactions, and so on, which we are considering feedbacks, we are considering in a more detailed way. So this is known as Earth system model, where biosphere is actually playing a role, and the variation of biosphere or adaptation of biosphere, or the way the biosphere is sensitive to the climatic condition, this is being taken care. Now, when we are talking about Earth system model simulations, so we are essentially interested at how our 2100 will look like. And this is what we are trying to find out through Earth system model. But for understanding how the future will look like, we need to understand the model needs some input. And one of the input is what will be the carbon dioxide concentration or carbon dioxide emission in the future, because this is a very uncertain thing. So there are certain scenarios which are denoted by representative concentration pathway scenarios. One of the best scenario or good scenario is RCP 2.6. This tells us that human will start increasing the greenhouse gas emissions, but after that they will understand, they will start reducing, so that at the end of 2100, the radiative forcing will be 2.6 watts per meter square. There is another scenario which is probably the most probable scenario, that is RCP 4.5, that tells us that human till 2050 they will start increasing the greenhouse gas emissions, but after that they will realize and they will stop at that level. So that is RCP 4.5. Then RCP 6 and 8.5 are the bad scenarios, where greenhouse gas emissions will keep on increasing, that results into more radiative forcings. And when you are extending it beyond 2100, they are known as ECP scenarios, or extended concentration pathway scenarios. Now, RCP and ECP scenarios are also coupled with shared socioeconomic pathways. That means what are the different socioeconomic pathways, and in what way these socioeconomic pathways can be connected to RCP scenarios. For example, SSP1 scenario is talking about sustainability. So as it is relating with sustainability, it is related to one of the lower RCP scenarios. So SSP1 is normally coupled with RCP 2.6, even RCP 1.9, and so on. But let's say if you're talking about SSP2, which is middle in between, they are coupled with RCP 4.5. So we call it SSP2 RCP 4.5 scenario. SSP4 is more on inequality, so they are coupled with RCP 6 scenarios. And one of the worst scenario is fossil fuel development, which is SSP5. And this is, of course, coupled with the worst RCP scenario, which is RCP 8.5. Now, if you run these models, you'll get the global temperature with respect to 1850-1900. And you can see these are the scenarios: SSP1 1.9, SSP1 2.6. And as you are going for a worse scenarios, your climate change projections are also becoming worse with more warming condition. Now, let us try to understand how the hot extremes will look like. And for this purpose, IPCC has come up with a very nice picture which came in the summary for policymakers. So let us try to understand extreme event. Extreme event means what is happening, one in 10 years kind of event, or 1 in 50 years kind of event. Let's say if you are interested in 1 in 10 years kind of event, so which has been happening over pre-industrial period, let's say 1850 to 1900, you can see that 10 dots that denotes 10 years in the pre-industrial, and once in 10 years, which one is hot heat wave years, this is denoted by a dark plot. Now, at the present condition, that 1 in 10 years has become almost 3 in 10 years. You can see now 3 dots. At 1.5 degree global warming level, the heat waves will increase 4 times. So it will say 4.1 times compared to the in pre-industrial one. And 2 degree warming, it is becoming 5.6 times, and 4 degree warming, it is becoming 9.4 times. Almost all the years are becoming extreme heat wave years. The other problematic part is that more rarer events. So essentially, rarer events are occurring more and more times. So the increase is more over the rarer events. So if you consider 1 in 50 years event, that is rarer event compared to once in 10 years. So that at 4 degrees centigrade warming, you can see that 40 times increase in the occurrence. So you can see that what sort of increase we are seeing if you are going for uncontrolled carbon dioxide emissions and so on. So our target is 1.5 to 2 degrees centigrade warming. We have to restrict, but if it goes beyond that, it is simply uncontrollable, and you can see that. For extreme precipitation, you can see that 1 year, 10-year events is becoming, it increases by 3 times, and for drought, 1 in 10 years event is increasing by 4 times. So everywhere. So the worst part is that all the extremes which are bad for us is actually increasing in a warming environment, and which is not really a very good thing for us. Now, the other thing which has come in IPCC report is about compound extremes, and which is very important for the regions like South Asia and Southeast Asia. Let us try to understand what does it mean by compound extremes. So compound extremes means when two extremes are happening together. Let's say if you are talking about tropical cyclones. So when tropical cyclones happens, what is happening is that there's a huge wind velocity that is coming with extremely heavy precipitation. There is a storm surge, and let's say in future if the sea level is rising, or at the present condition also sea level is rising, then what is happening, the inland water, it cannot go out, the flooded water cannot go out very easily because of the sea level rise. So altogether, the tidal flood, the storm surge, the extreme rainfall, the extreme wind, all of them are happening together, and managing all of these extremes are really, really difficult. So compound extreme means when all of them are actually happening together. And you can see that the sea level rise is actually happening over the South Asia and Southeast Asia. That's what IPCC report based on the scientific literature shows. And this kind of compound extremes will be a major threat for the South Asia and Southeast Asian region. And similarly, another kind of problem will be drought and heat waves. Let's say drought and heat waves are happening together. That also results into compound extremes. So the challenging part is that we are actually worried about extremes, but we have to be worried about now compound extremes, when both of them are happening together and happening together, and also increasing together. So that's really a challenging part. Now let's say if you are focusing on South Asia, the key message for South Asia is something like this. So one of the thing is that the South Asian monsoon has actually reduced, and for that it's not really global warming, but it's because of the pollution. The aerosol emissions have increased over the North Indian landmass, that resulted into decrease in the thermal contrast and the wind that is coming from ocean to land, and because of which the monsoon has reduced over the South Asian region. But in future, the good thing is that it has been shown that greenhouse gas emissions will overtake the aerosol emissions, and because of which we are expecting an increase in monsoon rainfall. But at the same time, the extreme rainfall are increasing. We can say monsoon rainfall is increasing, as well as extreme rainfall is increasing. The heat waves are increasing, the sea level rise is increasing, and there is a decrease in the snowfall or snow accumulation or the glacier accumulation, which is not really a very good story, what we are waiting for in the future for the South Asian region. In fact, same thing is happening over the Southeast Asia also. There has been increase in extreme precipitation, increase in sea level rise, and and increase in heat waves. Now, the one of the thing what I'm trying to say is that, of course, we understand we are in a problem, but just talking about problem without providing any solution will actually create more problems, or will sort of paralyze the system rather than solving it. So we're actually at IITB, at a technological institute, we have been working on multiple problems towards sustainability. So we are focusing on the problems, the technology development that can deal with problems like climate change, which can be climate resilient system, design of design of system which can absorb the threats like climate change and so on. So here are a few which I'm showing. One of them is urban flood forecasting systems. The second one is flood risk forecasting, then flood evacuation, irrigation water management, and so on. So urban flood forecasting system, this has happened, this was India's first real-time urban flood forecasting system for the entire city, and which starts with the weather forecast to the 3D visualization of the forecasted flood. And this is the project which started after a severe flood that took place in one of the city in India, Chennai, which took 500 lives. So after that, upon the request of principal scientific advisor to the government of India, IIT Bombay led a team of 30 scientists from 8 institutions and national lab, and we started developing the real-time urban flood forecasting city for the entire city. So let's say this is the city; it is a coastal city, and I know that most of the South Asian many South Asian coastal cities are there and Southeast Asian coastal cities are there. So this is a city which has a very difficult, complicated drainage system, buildings, roads. These are old cities. The DEM is very difficult to get. So that has its own challenge to really model the flood. In urban regions, we expect the rainfall to increase and which has a very high spatial variability, which is another challenge. There are upstream reservoirs and upstream watersheds where also if you get extreme rainfall, this will affect flooding over the city. That's the third thing. Fourth thing is that being a coastal city, we will also see storm surge and the cyclones. So all of them we have to consider together. So we have developed different modules like rainfall modules, which is rainfall forecasting. We have a global model, then a statistical downscaling model, then we have a nowcasting with radar data. Then we have the coastal conditions, we have the tidal floods, we have bathymetry. We have to consider the upstream hydrologic condition, we have to consider terrain condition, and we have developed an expert flood simulation system, which forecast flood for next 3 days. And this was done with a record time, and 1.5 years everything was done. Everything was developed. So every day at 3 p.m. the Meteorological Organization of India, India Meteorological Department, they release the forecast. It's at 3 p.m. every day. Now by 5 p.m. we can do the statistical downscaling, tide forecast, after upstream hydrologic forecast, past condition, everything we can get. But when you catch an urban flood model, it takes a long time because we are running the model at a very fine resolution of 2 meter to 10 meter resolution. So it takes a long time to run a flood model. So it may so happen that by the end of the flood model simulations, you will see the flood has already come. So what we did, we have generated a huge number of around 900 simulations we have generated for different tide conditions, different upstream hydrologic conditions, different meteorological conditions, and generated the flood inundation maps for different conditions. Now, as soon as we'll get all this information, we go to the data bank and find out the closest scenario. And based on that scenario, we generate the day 1, day 2, day 3 flood maps for the next 3 days. Now, at the same time, for the evacuation, we also need to run a real-time flood. So we will not start the real-time flood if we see that at higher quantile we'll get a flooding condition. We'll only start when you are seeing a flooding condition from this scenarios which we have generated, which are already generated. So this is the way the entire simulation goes, and it shows something like this for every day. For the next 3 days, given a forecast for different quantiles of rainfall, 80th quantile, 85th, 90, 95th, 99 quantile, what are the different flood inundation map that can be generated. In fact, you can click on it. You can go even at a building level and see that whether that building is getting inundated or not in next 3 days or not. So this sort of information is possible to generate with this kind of technique. Now, after that, there is, I hope I have 5 minutes more time, right?
Actually, the time is already finished, Professor, but if you want to wrap up in maybe 3 minutes, it will be okay.
Yeah, because I started quite late, 20 minutes late. So
yeah, it's okay, Doctor. It's okay, Professor.
So I finished 25 minutes. I have 5 minutes, but I'll try to complete before that. Yeah. So the second one is about forecasting flood risk over a large region. This is another challenging task. So let's say if you're talking about over a urban region, that's easier. But if you're doing it over a large region, then we have to prioritize inundation in certain regions. So, and one of the major problem with the existing model is that you have a weather model, you add a hydrologic model, you add a hydraulic model, get the visualization and so on. But what we keep on missing is that the weather models have a lot of problems in terms of false alarm and mixed hits, low hit rate, we'll say. And also there are regions which are vulnerable more. Let's say the person who is living in 20th story, they may not be affected much by flood rather compared to those who are living on the street. So there are regions which are more vulnerable, and also there are certain land use land cover which are more exposed to flood. So first what we consider, we took the weather model, take the hindcast, the way it is performing over the past, and from there we are computing the probability of extreme rainfall tomorrow given a forecast for tomorrow. This is the probability of hazard. This is multiplied with vulnerability based on census data and exposure. That will give you real-time forecast of flood risk. And this is applied for one of the southern district of India, Kerala, and we can see 2018 there was a huge flood that resulted into huge loss. So we wanted to check this, and what we found first is that the regions where the rainfall were very high, the flood loss was not very high. That shows that vulnerability is important. And then we found that the forecast is only showing, if you're considering the forecast, only lead day 1, it is showing extreme rainfall. So the forecast was also not working. Then we developed our methodology and applied it with a proper hazard, vulnerability, and exposure method. And then we can find is that from lead day 10, it started showing the even the high alert zones. So it showed very nicely the high alert zones where the flood risk was very high, but it missed one of the region. What we have also found that it completely missed one of the district where the flood loss was very high, and we found that it is because of landslide, and landslide model was not really included in. So this can be further improved. The third one is that once we have this flood hazard information, how can we evacuate people? And this kind of evacuations were really very challenging during the COVID time, because the shelters, if you overcrowd them, there will be a outburst of infections. So we have applied it for one of the state in Orissa, one of the district, which is a flood prone district, and these are essentially the high flood risk zone area, and these are the shelters. So the idea here is that how to really evacuate the people and keep them in shelters. You have to increase the number of evacuees, and you have to reduce the number of infections. We have developed a nonlinear optimization model, and we have showed that with this kind of models, some unique, I mean, of course, there are certain unique ideas which are infused into the model, and it shows that it is possible to reduce 20 to 25 number of infections per shelters if you use this kind of models. And this can take care of most of the evacuations which is happening, who are living in the kacha houses or who are living in temporary houses. And the final applications is more on in what way we can use weather forecast for irrigation water management, because groundwater depletion is a major problem over South Asian region. So we talked to the farmers, and we realized that farmers do not really follow weather forecast because they do not know how to do it. So this is a participatory model where we tried to understand the farmers model. We applied our techniques into that with a soil moisture sensor, with weather forecast, with a probabilistic rainfall scenario generation, and optimization model development with a constraint that your root zone soil moisture with certain probability is not going below a water threshold. And what we found is that we applied it to some of the grape farmers, and what we found is that it's possible to save around 10 to 30% of water using this kind of weather forecast. So if you can improve the weather, if you can improve the climate services in terms of weather forecast, that will save us a lot, and that probably give us some sustainable approaches or sustainable solutions. So thank you for your attention. I'll be happy to answer any questions if it is there.
Thank you so much, Professor Subimal Ghosh, for sharing us your wonderful research on global and regional climate change. And now we can proceed to the next sessions, which is Q&A sessions. However, due to the time constraints, I will just deliver some of the questions we have received through the link, okay? So the first questions will be from Donavel from Philippines. A questions for Dr. Somporn. What happened to the solar cell if there's no enough supply of water because of climate change? So Dr. Somporn, are you still here?
Okay, yes, thank you. Yeah. Your question is what happened with the solar cell if
what happened to the solar cell if there's no enough supply of water because of climate change?
Solar cell and with the water,
is there any explanation for that?
Normally the solar cell is also get from the sunlight, right? Yeah, and it's just related to the sunlight, the radiation, solar radiations for the light intensity. So I think it's, you also have every day, right? But okay, maybe some part that you have a lot of cloudy or something like that, and then maybe that is the part of the you cannot produce as much as that you need, right? But maybe you have to find out another resources of the renewable energy from maybe wind or wave or water. It depends on the situation. I think in that one you have to declare or check for the ability available of the natural resources from the energy. Yeah. But for the effect from the water, I cannot understand. For that, I am not sure what is the yeah, maybe yeah.
Yeah,
Shall
maybe
I?
Professor Ghosh will add.
Yeah. So I think it's an important question. So the question is, if I've understood correctly, if the if the supply of water is getting reduced, then what is the solution? And that's a very important question. So in fact, if you look into South Asian region, specifically for South Asian region, the population is increasing, and because population is increasing, you need to intensify your agricultural activities, and we need more water. But what is happening is that majority of the water that is coming as rainfall, that is an extreme rainfall, so it goes away. So the freshwater supply is getting reduced. Once the freshwater supply is getting reduced, we are actually in trouble. The solutions are few. I mean, of course, the first thing is that, of course, you have to recycle water and reuse. That's the one of the things. Second one is that rainwater harvesting. So you have to improve your rainwater harvesting techniques so that you can harvest the rainwater. The third thing is that we have to go for low water intensive crops. Like if you are going for paddy like crops, that takes a lot of water. But let's say if you are going for low water intensive crops like millet or maybe like sorghum, this kind of crops, they need less water, but they produce slightly higher or similar kind of kilocalories. So this way you can actually handle a lot of issues related to water, energy, food nexus, and the water related problems. Thank you.
Okay, thank you.
Okay, thank you so much, Dr. Somporn and Professor Ghosh, for answering the questions from Donafel from the Philippines. And the next questions, also from the Philippines, how does climate change affect the food supply? Maybe Dr. Sheeba will answer these questions because it's related with your presentation.
Because the crops can be affected by the reduced water stress. The productivity can be affected. So it depends on what kind of impact that in the particular region you're going to get. I think most of the the future scenarios for the Southeast Asia said, and also I think the research showing the downscaling of the CMM 5 model, CMM 6 models, right? For our area, it was mentioned that, especially for Malaysian region, it was mentioned that there will be the monsoon will be less, and there will be more drought and we can expect more drought. So because of that, there will be water stress, and definitely there will be impact on the crop production, decrease in the impact, decrease in the crop production.
Thank you so much, Dr. Sheeba. Maybe Professor Subimal will add something related to how climate change affect the food supply.
Yeah, thank you. I agree with Dr. Sheeba that she has very nicely pointed out in what way it will affect the food security. So one of the things which I'd like to highlight here is that if you're considering the mainly over the South Asian region where there is a huge population growth, and as I was mentioning that we need more water because we are actually losing a lot of water in terms of extreme rainfall. And now what is happening, your water demand is increasing, but your water supply is getting reduced. When your water supply is getting reduced, you need more and more water, and you are actually doing a lot of irrigation. So a lot of groundwater pumping, and when you're doing a lot of groundwater pumping, what is happening, your groundwater is getting depleted. So let's say this year it is at this level, next year it is at this level. So you need more money, actually more energy to pump this groundwater. So your food cost is agricultural cost keeps on increasing. So that will affect on the crop price and so on. So that will again affect the food security. So there is a direct impact, there are indirect impacts. So we are actually in a trap, sort of, where it's a food, energy, water trap, and we have to come out of this maybe with a better sustainable technologies. But this is the present situation. And in fact, I'd like to mention is that IPCC Working Group 2, Year 6, which was published in February, it has very clearly said that we are actually in trouble in terms of food security. Climate change is affecting food security in a bad way, and with high confidence they have said that whatever available technologies are there, they are not really sustainable in terms of meeting the food and water demand together. So we have to think of out of the box thinking to really solve this kind of challenging problems, and more regional technologies are more important. So we have to understand that specific region, and based on that region, we have to think of development of more participatory models and participatory techniques. Thank you.
Okay, thank you so much for all speakers. And I would like to deliver another questions in the chat box by Mr. Sigit Amalik. I guess it's Professor Subimal can explain these questions. Mr. Sigit asked about, does climate change cause more earthquakes? Do you mind to explain this, Professor Ghosh? Thank you. You're still unmute. I'm sorry.
Sorry. So
Yeah.
at this moment, there is no strong connection that shows that climate change results into earthquake. I remember there was a paper which was published very recently, which talked about, when there is a change in pressure, that results into some sort of a slow or mild kind of earthquakes. The kind of pressure that results into, creation of hurricanes and so on, that may result little bit, but there is no strong connection with which we can with high confidence we can say that climate change has a direct link with earthquakes.
Can I add something?
Yeah,
Sure,
please,
Dr. Sheeba.
Because in polar region, when there is melting of ice, as Professor Ghosh said, the earthquake is related to platelet movement, volcanic eruption, and all those things. But recently, there were few research showing that when there is melting of glaciers, it can cause instability. And it can cause earthquake. And also permafrost melting, that means the soil that is very solid, it's kind of rock, but when there is warming, this permafrost can become kind of softer, and this can cause instability, causing earthquake. And also the thermal expansion of oceans, right? It also can cause some instability. Then there will be like increase in the number of earthquake.
Yeah, thank you so much, Dr. Sheeba, for adding this additional informations. And I have one final questions from Miss Ariani from ITS. Miss Ariani asking to all of the speaker here. She's asking, the huge contributions for climate change is a human behavior. On your personal opinion, how to change the behavior of society, because it is hard challenge to change the society to be more friendly with environment. Okay, do you want to start, Dr. Somporn? Maybe
Okay.
how to change? Yeah.
Yeah. Okay. As I show, first of all, thank you very much for the question. And as I show you about the how can we also apply for the household level or community level in order to find out your way in order to adapt yourself to the situation. I mean, it's you have to think about the natural disaster and how to manage, how to prepare, and then also think about the energy, think about the water supply, about the food security, and also even the people with behavior. How can you collaborate together with the different group, different zone, different area in order to know something in a proactive way. I mean, not only to think when the something come, but you think before in advance, try to analyze thing in advance, and before what happened, like a 10 days before, one month later, 1 month before, or 1 year before, thing like that, and try to analyze the community and household level, and then try to adapt in the locally also. And after that, I think it will be grow for the globally also. Hopefully that if you can manage, like even what I do, I try to play show in the part of the SDG 7, but actually related to the climate change. I am also doing the part of the modeling in the climate change, also even in the prediction, daily prediction, thing like that. And I think important thing is people should be like climate change literacy or something like that in order to find out the way in the local region, because it's for everywhere, it's not the same situation, right? yeah, something like this, I think it's mostly should be okay. Yeah, thank you.
Yeah, thank you so much, Dr. Somporn. Dr. Sheeba or maybe Professor Ghosh, do you want to continue the answer?
Dr. Shiva, please.
Yeah, there are a lot of things you can do at the personal level, right? You can try to reduce your carbon footage. There are so many actions that you can take to reduce the emission of all the greenhouse gases. And also youth, right? You have the power. You can influence your policymakers to make, laws that will allow to decrease the amount of greenhouse gases that is going into the atmosphere, because we know that the reason is the increase in the greenhouse gases. So it is not impossible, but there should be drastic changes in the lifestyles. And also there should be, some kind of a law to decrease the amount of greenhouse gases that is going into the atmosphere. Yeah, I think, and also the literacy, climate literacy, right? It is called like what do you call the personal influence to your peers. So I think that are the things that we can do, right? So you do your part, then let us hope for the best. That's all from me. Thank you.
Yeah, I mean, one of the thing what I'd like to mention is that over the South Asian region and Southeast Asian region, we are a bit lucky in the sense like, the huge proportion, a huge fraction of the population believe that climate is changing. Our governments believe that climate is changing, and there are a lot of initiatives that have already started taking place, which is a very good thing, which is not probably happening in many of the Western countries, but that's really happening over this region, which is very good. I mean, one of the things what you have to understand that all these greenhouse gas emissions and warming, this has started from the Western countries, and now many of them probably have started understanding, few of them don't understand, and so on. But we have been affected quite severely. But the good thing is that we are now really understanding this, and we are coming up with the climate action plans. I have been seeing that many of the countries, like as for example, India has said that by 2070 we are going for net zero. In some of the states, they are starting within India, they are talking about by 2050 coming with a net zero plan. So this every state in India is coming up with state action plan on climate change. So these are really very positive thing which is actually happening. People are believing, and they are actually supporting this kind of initiatives, which is very good. And I think the countries of our South Asia and Southeast Asia, of course, many of the Western countries have taken a leading role resulting to global warming, and but most of the countries of South Asia and Southeast Asia probably taking a leading role in saving world from the global warming. So that's my hope. Thank you.
Thank you so much to all speakers for these final questions. So I believe this event will inspire us to start small step to achieve affordable energy and clean energy and prevent climate change. Thank you so much once again.
May I challenge you something? May I challenge you something? For example, all together. For example, our globe is also spherical shape, right? And then we also have the sunlight also shine to our spherical shape all the time, right? And actually, if you define that another this our time here is like in the night time, for example, and another side is also in the in the daytime, right? And actually, if we like make MOU together, make a grid, like a global grid, for example, then it's possible to transfer the energy from another side to another side via the international grid, something like that. And it is just the idea, you don't have to think of the clean energy with the SDG 7. Okay.
That's just so interesting, Dr. Somporn.
Thank you so much. Challenge you, yeah. Okay.
Yeah, we have a little challenge from Dr. Somporn here, and yeah, thank you so much once again to all of speakers for today. It is really interesting and wonderful to see and hear from your expertise regarding SDGs number 7 and also 13. And before we close today's meeting, I will give a highest appreciation to all speakers for the excellent lecture today. And we would like to present a certificate awarding to our speaker. Committee, are you ready? So the first certificate is dedicated to Dr. Somporn Chuai-Aree from the Thailand. Once again, thank you so much, Dr. Somporn, for your contributions in this meeting. And yeah, and the second certificate presented to Dr. Sheeba from University of Malaya. Thank you so much, Dr. Sheeba, for your participations. And the last but not least is a certificate dedicated to Professor Ghosh. And we will later send the fully signed certificate to your postal address along with a humble gift from us. Okay, thank you so much once again for sharing your valuable insight with us today. So before we end our lecture today, we invite all participants and also the speakers, of course, to have group photo sessions. So therefore, we would like to request all participants to open the camera for a while to have a group photo sessions. So dear committee, please help us with photo session. Okay, I will count in 3, 2, 1. Once again, maybe in 3, 2, 1. Okay, as we have finished the group photo, I will finally close the meeting. I hope to see you in the next GLS, which is tomorrow. We will still have another great sessions with also the great speakers from other countries. So please stay tuned with us in the tomorrow sessions. And all for the participants, I have also announcements. Don't forget that the first assignment of That's What I Learned should be submitted by March 18, 2022. And the second That's What I Learned should be submitted by March 31st. Okay, so please submit your worksheet through the link that has been given by the committee in the chat box. And thank you and happy SDGs learning. So yeah, see you in the next event. Stay safe and healthy. Bye.
Bye. Thank you. Bye.
Thank you very much for having us.
Bye-bye. Thank you.
Thank you so much, Dr. Sheeba, Professor Ghosh, and Dr. Somporn. Bye.
Thank you very much, Dr. Somporn, Dr. Sheeba, and also Prof. Subimal. Thank you very much for your valuable lecture. Thank you.
Thank you.
Thank you.
Bye. See you.
Bye.
Yeah. Okay, thank you very much. And for participants, don't forget the assignment, TWIL, and we will see you again tomorrow with another GLS on SDGs. We will see you again. Let me end the session in